Hi, welcome to our electromagnetic theory course. In this video, I will derive Poisson's and Laplace equation by using Maxwell's equation. That Maxwell's equation is nothing but del dot D equal to rho V. Already we derived this Maxwell's equation by using Gauss law for electricity. Okay, Poisson's equation is this one, that is del square V equal to minus rho V by epsilon, whereas if this one is equated to 0, then that equation del square V is equal to 0, that is called as Laplace equation. Now we will derive this Poisson's equation by using this Maxwell's equation, that is del dot D equal to rho V. If you see here, in case of the Poisson's equation, we have del square V, means what? Del dot del is nothing but del square, that means we require two dels, but here I have only one del from this Maxwell's equation, means what? I need to modify this equation to get del square. So that's why initially I consider Maxwell equation like this, that is del dot D equal to rho V, means Poisson's equation can be derived. It is derived from Maxwell's equation. That Maxwell's equation is del dot D equal to rho V. I can write this del dot D is like this, that is del dot D can be written as what? Epsilon naught into E. Epsilon naught into E equal to rho V. Okay, as epsilon naught is constant, we can write this one like this, that is del dot E bar is equal to rho V by epsilon naught. Let us take epsilon naught. Okay, let us consider free space del dot E equal to rho V by epsilon naught. But we know that, but E equal to what? But E equal to, we know that minus del V. Minus del V. Substitute in this one. Therefore, del dot E is equal to, therefore, del dot E can be replaced with what? E can be replaced with what? Minus del V equal to what? That is, here we need to replace this one with what? Rho V by, okay, del dot E can be replaced with minus del V, since E equal to minus del V, rho V by epsilon naught. We know that E equal to what? Minus del V. Okay, if you want clarification, please refer the video. Title name is the relationship between E and V, differential relationship between E and V. Okay, we know that here, that is del dot del gives what? Del square V, and here I have minus sign, multiply with minus on both sides. Here minus into minus, that gives del dot del square, minus into minus plus del square V equal to, here that is minus rho V by epsilon naught. This equation is known as what? This equation is known as what? Poisson's equation. Poisson's equation. Poisson's equation. Or else, okay, for any medium it is what? Epsilon is the permittivity of the medium. In that case, it is nothing but what? Epsilon only. Here also epsilon. Okay, for the given medium, if the medium is linear and isotropic, means what? In that case, epsilon is constant. We can write that epsilon outside of this del, if epsilon is constant. Okay, for the given medium, epsilon is constant. So that's why we can write that one outside of this del dot, means we can send this term to this side. Again, we can write this epsilon this side. Okay, finally we got del square V equal to minus rho V by epsilon. This equation is called as Poisson's equation. Okay, suppose if the medium is free of charge, if medium is free of charge, if medium is free of charge, if medium is free of charge, or else if the region, if the medium is source free region, in that case if there is no charge, so for that case, if medium is free of charge, then if medium is free of charge, that means what? That is, medium is free of charge means there is no charge in the medium, means there is no charge density. In that case, rho V equal to 0. Rho V equal to 0. So if rho V equal to 0, then above equation becomes, okay, if the medium is free of charge, in that case, if the medium is free of charge means what? There is no charge. In that case, this one charge becomes q is 0, as q is 0 rho v is 0, charge density is 0. In that case above equation becomes del square v equal to 0, del square v equal to 0. This equation is called as del square v equal to 0. This equation is called as what? Laplace equation. This equation is called as what? Laplace equation. This equation is called as what? Laplace equation. What is Laplace equation? Laplace equation is nothing but the Poisson's equation, special case of the Poisson's equation. Here I have Poisson's equation. Okay. In the Poisson's equation, if rho v equal to 0, that is called as what? Del square v equal to 0, as rho v is 0. Means what? Laplace equation is nothing but the special case of the Poisson's equation. This is all about the derivation of Poisson's and Laplace equation by using this Maxwell's equation. Very simple. Poisson's equation is given by del square v equal to minus rho v by epsilon. Here I have two dels, del square means two dels, but in the Maxwell's equation we have only one del. That means what? From this equation we need to get del square. So that's why first consider this del, and in order to get another del, because we require del square, so write down this d in terms of what? E, because E can be written in terms of the del. So that is E equal to minus del v. Substitute that E equal to minus del v in this expression, we will get what? Del square v equal to minus rho v by epsilon. This equation is called as Poisson's equation, and this equation is called as the Laplace equation. Laplace equation is nothing but what? Special case of the Poisson's equation if rho v is 0. If rho v is 0 means what? If the medium is free of charge. Okay, so that means what? Laplace equation is the special case of the Poisson's equation. This is all about today's video. We will meet in next video. Thank you.